Finding horizontal and vertical asymptotes of a rational function, quadratic, numerator, or denominator. So having a quadratic, that's going to be a degree 2. So when you first encounter this topic, you may be dealing with rational functions that are just there's a little more going on with them than what you've had to deal with previously. So we have here f of x equals 3x plus 1 over x squared minus x minus 6. So the vertical asymptotes always come from the denominator. Yeah. So we're going to deal with that in just a second. The horizontal asymptote is kind of, you look at the function more holistically, and you kind of have these 3 different cases for the horizontal asymptote, depending on the degree of the numerator, so degree 1 in this case, versus the degree of the denominator. So if you have the degree of the numerator is less than the degree of the denominator, which is what we have here, right? 1 is less than 2. Then you actually don't have to really do much. Your horizontal asymptote is just going to be y equals 0 or the x-axis. So we'll look at one where we have same degree would be maybe case 2, and then if the degree of the denominator is greater than the degree of degree of the numerator is greater than the degree of the denominator. So like case 3. So by the way, case 3 is none. There's no HA, no horizontal asymptote. And this one, you do the ratio of your leading coefficients. Something kind of like that. But anyway, we'll look at a couple where you have that. This is not exactly applicable for this particular guy. So, okay, for then our vertical asymptotes. So you want to take everything that you see and factor your function, and then kind of look at the denominator. So what we have to be careful with is to make sure that we are not going to have a hole. So if we have a common factor in our numerator and denominator, that would be a hole, and we wouldn't use that for a vertical asymptote. This one, I don't think that's going to happen, but let's just, to be sort of consistent, let's go ahead and write it out. So 3x plus 1 doesn't factor further, and then x squared minus 6, I believe, would factor as x minus 3x plus 2. So we're looking for 2 numbers to get the minus 3 and the 2. These are the 2 numbers that multiply to negative 6 but add to negative 1. So I notice that there's no common factors to cancel. So now I can feel confident that both of these factors that are in my denominator are going to give me vertical asymptotes. So I'm setting each of these equal to 0. So we get x equals 3, x plus 2 equals 0, so we get x equals negative 2. So we get 2 vertical asymptotes for this particular function. So this function has 2 vertical asymptotes, 1 horizontal asymptote. So by the way, you can get more than 1 vertical asymptote, but you either have 1 or none for the horizontal. And that's all they asked us to find. If we wanted to find intercepts, like for a future topic where we have to do more stuff, then it's not too bad to find the x-intercept. You would just set the 3x plus 1 equal to 0. X-intercept comes from 3x plus 1 equals 0. I think you would get negative 1/3. Y-intercept is even easier. You just zero out all your x terms. You plug 0 in for x, so it looks like it would be 1 over negative 6, or negative 1/6 for the y-intercept. But that's outside the realm of this topic. Okay, so let's do another one of these. So, vertical and horizontal asymptotes. Okay, so this one's going to be just a little bit different. So notice that we have in our numerator, the degree is 2, and in the denominator, the degree is 1. So for our horizontal asymptote, the numerator degree is larger than the denominator degree. So 2 is greater than 1. That means there's not 1. So there's no horizontal asymptote. Okay, well, that's nice. All right, so then for our vertical asymptotes, we need to make sure we're not going to have any common factors, and I think with these that you're not, but just in case, So I'm going to factor everything I can. So the x squared plus 5x plus 6, that's quadratic, so I can probably factor that, and it looks like it would be 2 and 3, x plus 2, x plus 3. And then the 2x plus 1, since that's linear, you can't really do much with that. So we can see, okay, there's no common factors. So there's not going to be a whole. So that means for my vertical asymptote, it is just going to be take the denominator, 2x plus 1, and set it equal to 0. And since that's a linear denominator, we're just going to get the single answer. Looks like negative 1 over 2. Negative x equals negative 1/2. So we get one vertical asymptote and no horizontal asymptotes. Just by the way, it's easy to see the x-intercepts for this one. They would be negative 2 and negative 3 coming from the numerator. So you just set the numerator equal to 0 for your x-intercepts. All right, and then a couple more just to see some of the different possibilities. Ooh. So it's actually possible to get 0, to get no vertical asymptotes as well, even though you have x's in the denominator. But first off, let's talk about the horizontal asymptote for this particular one. So now we've got that other case that we haven't seen yet where the degree of our numerator, b1, is strictly less than the degree of the denominator. So in that case, we do have a horizontal asymptote, and it doesn't matter what these coefficients are, the horizontal asymptote is y equals 0, or the x-axis. Okay, so let's talk about, so we've got that guy. So let's talk about our vertical asymptote. So x squared plus 1 does not factor. Some people think it factors as x plus 1 squared or as x plus 1, x minus 1, but it doesn't. You can multiply these out and you'll see that you do not get x squared plus 1. It just doesn't. So we're definitely not going to have any sort of common factor to worry about. And when we set x squared plus 1, our denominator equal to 0, we are going to get non-real answers. So if we go ahead and sort of follow this through, we would get x equals plus or minus I. You can't plot the vertical asymptote x equals I, like that vertical line, that there's nowhere to put it on the graph, at least not the graphs that we're doing. So if you get imaginary answers, values, then you just get rid of them. So this is, since all we got was either I or negative I, and we have to omit those, we say none. So there's no vertical asymptotes for this particular one. So I'm trying to think what this guy would look like. I'm not sure exactly what it would look like. It would be a little tricky to try and just graph it really fast. But with all of these functions, you can either go to Desmos or use your graphing calculator and just double check, especially as you're learning, that the graph seems to match up with what you're finding. So we do get an x-intercept of 1/5, and it goes through the y-axis at 1. So I don't know, maybe that's 1/5. So I'm not exactly sure what this looks like. I'm thinking, though, it might kind of look like this. So it gets kind of sucked to the x-axis to create that, but I don't know if that's right, actually. So just maybe pretend like I didn't draw that. Okay, so then let's do just one more. So this is going to be, again, a little different. Looking at our degrees, we see that we have the same degree. That means we are going to have a horizontal asymptote. It's going to be y equals the ratio of the leading coefficients. So y equals 3 over 2, and that doesn't simplify, so that's the answer. For our vertical asymptotes, so we could, I think we might be able, can we factor I think we can factor the numerator, but in the interest of time with this video, the only reason to do that, if all you're looking for are the asymptotes, is to make sure you don't have any common factors. And I'm looking at this denominator here thinking about vertical asymptotes, this denominator isn't going to factor. And so this is going to be similar to the last one. So if you have some kind of x squared term plus a number, so your two terms, your x squared term and your number are the same sign, then you're going to only end up with imaginary solutions, setting that denominator equal to 0. And so this is going to be like the last one. We're going to end up with no vertical asymptotes, but just to see what it looks like if you kind of followed it out. So we have negative there, and dividing by 2, negative 9 over 2. Take the square root of both sides. Oops. And so we could simplify the square root a little bit, but the point is we're doing square root of a negative value. We're going to plus or minus something with I. So this is going to be, again, none. All right.